So here are your notes for Unit 7.5. Two objectives: be able to sketch a graph, be able to sketch square root graphs including shifts, be able to sketch cube root graphs including shifts also. All right, so let's move on here. So we did a little bit in class just describing where these came from. So you guys should have all that. So they're basically inverses of the square, x squared, and x cubed. So the inverses of that. So going to the graphing form, so the square root form, cube root form. One thing to make sure you guys remember is that the inside is opposite. So we went over this in class also. H is your horizontal shift, so that's left and right shift. K is your up and down shift, that's your vertical shift. All right, so the parent graphs, we went over that in class 2, so I'm going to go over those. So example 1, so we'll start with this one. Okay, so we're describing how to get this first part from this second part. So basically all these type of questions are asking is about the shift. So there's your shift right there and right there. That's your H and that's your K. So your H is this x plus 1, but remember inside opposite, so it's actually a minus 1. So the insert part moves it left or right. So since it's a plus 1 and you want to do the opposite, you actually say you're going to go to the left one. So left 1. And then that's a negative 3 for your K. K is your up and down shift. So that's just going to take it by what it says and go down 3. So in order to go from here to here, you go left 1 and down 3. Okay? Same thing here. You start with a basic graph. You're moving up to a more complex graph. So we are looking at our shifting here. So that's your shift, and that is your shift also. This negative 5 is not a shift. That's not an H or a K. That's also included right here. So those are basically the same thing. You just want to notice what the shifting is. So since it's a negative 8 inside of the radical, that means that you're actually going to go to the right 8. So inside opposite, so you're going to the right, R-I-G-H-T. So right 8. And then positive 7 means you go up 7. So you're just going to go up 7. That is your shift. Okay. First set of work I'm going to give you guys tomorrow is going to be just about this type of thing. They're just going to ask you what the different types of shifting is. Okay, so number 2, I wanted you guys to graph this one, then state the domain and the range. So on the video right now, I'm just going to give you guys the graph. Tomorrow in class, I'll explain more detail what the domain and range are. So the way I want you guys to graph these is, since this is very complicated, well, not very complicated, but since it's somewhat complicated because you have an H and you have a K, here's what you should do first. To make it easier on yourselves so you guys can pick nice and neat perfect squares to go inside the square root symbol, we're going to rewrite this equation without the shifting. So if I can get my pin to work right. So you got y equals, I'm not sure why I did that, y equals 2 times the square root of x. So notice this is the same as this. I just took off the 4 and the negative 1. So let's go ahead and let's write down what these actually mean. So this actually means you're going to go left 4. And this minus 1 means you're going to go down 1. Down 1. All right, so we're going to make a table. And with this table, we are going to figure out some nice and neat x values. Now, keep in mind, you are taking the square root of x. Technically, you can pick just about anything for your x except for negative numbers, because we want to stay inside the reals. So you could pick a 0, you can pick a 5, you can pick a 10. But the thing is, a square root of a 10, that's not going to be a nice, neat number. So let's pick our numbers wisely. So the first number we should probably pick, you can just start with the smallest number, the largest number. I guess we can start with the smallest, is probably a 0. Or it is a 0. So the square root of a 0 is 0. But you got to multiply by that 2, so it's going to be 0 times 2, which is just 0 again. So first point, 0, 0. All right, so the next point, let's try a 1, because you can take a square root of a 1, so we're going to pick a 1. Now notice we're not picking any negative numbers here because the square root of a negative is going to be a complex. We don't want complex numbers right now, so we're not going to deal with that. So I just picked a 0, I picked a 1. Square root of a 1 is a 1, times 2 is 2. Now we're not going to pick 2 because the square root of 2 is not a nice number. So the next nice number Basically, we're looking for perfect squares. So the next perfect square is not a 3, it's not a 2, it's not a 3, 4 is a perfect square. So the square root of 4 is a 2, but then you got to multiply by this 2 and you're going to get a 4. Okay. So I think I gave you guys like a 10 by 10 graph, so let's go ahead and try one more. So the next perfect square from 4, 5 doesn't work, 6 doesn't, or 6, 5 isn't nice, 6 isn't nice, 7 is not nice, 8's not nice, 9 is nice, because the square root of a 9 is a 3. So square root of 9 is a 3, times a 2 is a 6. Okay, so those are your points. Now what we're going to do is, because that's not our actual graph, that is just a chart showing us what our points are before they got moved. Now let's move our points around to make it easier on us to graph. So x, y. Now I notated this was left 4. So what's going to happen here is this. Left is going to be along the x-axis. So if you're going left 4, that's the same thing as subtracting 4. So from all your x's, you're going to subtract 4. Now if you're going down on the y-axis, that means you're going to subtract 1. So from your y's, you're subtracting 1. So we're going to take all of our x values right here, and we're going to subtract 4 from them. So the first one is 0. So 0 minus 4 is a negative 4. Next one is a 1. So 1 minus 4 is a negative 3. Next one, 4 minus this 4 is a 0. 9 minus this 4 is going to be a 5. All right, so we shifted all of our x values. Now our y values need to shift also, and our y values are going to shift by down 1, so it's going to be minus 1. So take all of your y values and subtract 1 from it. So 0 minus 1 is a negative 1. 2 minus 1 is a 1. 4 minus 1 is a 3. 6 minus 1 is a 5. Now, to make sure that you're getting this right, you could always plug back in and see if it's working out. So for example, if you wanted to test out and make sure that you plugged in the 5 correctly. So if you take this 5 and put it into the original, 5 plus 4 is a 9. Square root of a 9 is a 3. 3 times a 2 is a 6. Minus 1 is a 5. So 5 5s. Looks like we did it good. All right, so now we're going to graph. Let's see here. So let's bring up the dual page and move this over. Okay, so here's our graph over here. Let me make this kind of bigger since. Okay. Okay. So first point is negative 4, negative 1. So negative 4, negative 1 is right here. Okay. Then you got a negative 3, negative 1. So negative 3. I'm sorry, negative 3, positive 1. So negative 3, positive 1 is right here. 0, 3. So 0, 3 is up here. And then you got another point at 5, 5. So 4, 5 up to 5. That is right there. Okay. So remember, these are kind of like they're half parabolas. So you start here and then connect all your dots up this way. Ooh, that looks weird. Okay. So sorry, it's not really smooth right there. Let's see if I can do that again. And he made it worse. Okay. No, that's kind of better. So that's your graph. Okay. So remember, your original parabola looked like this. Your inverse relation looked like this, but then we figured out, hey, this part messes it up, so we take this piece off, so all of your square root functions should look like half a parabola going this way. Okay, and that's basically what this is. All right, so next one. So we're going to do pair shares and stuff, but I'm just going to go over one example each. That way it's not too much for you guys. Let's switch this back full screen. No. So most of the time on your notes, you're just going to be watching me fill around and mess up my screen. So what was homework? Oh, just to watch Mr. Aguirre not know how to work a computer. Okay, so example 3. Graph the following cube root, then find the domain and the range. So once again, we're not going to do the domain and range right now. We're going to do that in class. So I showed you how to do a square root. Now let's go ahead and do a cube root. Now with a cube root, you're going to use the same technique because there's too much stuff going on. It can be confusing. So what we're going to do is we're going to go ahead and notate what the shifting is. So it's a +2. That means you're going to go left 2. Left 2. Okay. Minus 1 means you're going to go down 1. So down 1. Okay, so now that we have that, let's go ahead and rewrite it without the shift. So y equals 3 times the cube root of x. All right, so make your table. Now remember, we're going to try to pick, I'm not sure why it keeps doing that. We're going to try to pick nice, neat x values. Now by nice and neat, I mean that since we're taking the cube root, we should try to pick perfect cubes. This So this is going to be a little different than the one we did before. We have the cube root of x. Now this is going to be different because before we had just positive numbers. So let me go back here. Um, Wait a minute. Yeah, let's go back one more. Too far. Okay, so this one with the x's on the other example we did, you notice they were only positive because we only want to take the square root, but you can't take the square root of a negative. So the newer one that we have right here is a cube root. Cube roots can have negatives. So what we want to do here is we want to actually start this one in the middle with a 0. Okay? Now 0 is a nice and neat one because that's basically always where it starts when there's no shifting. So the cube root of 0 is a 0. 0 times 3 is a 0. So 0, 0 is first. So let's go positive up this way. So 1 is nice because the cube root of 1 is a 1. So let's try 1. So cube root of 1 is 1 times 3 is a 3. 2 is not so nice because there's no cube root. Well, there's a cube root of 2, but it's not a nice neat number. So the next perfect cubed would be 2, 4, 8. Okay? Because 8 is 2 times 2 times 2. So the cube root of 8 is a 2 times 3 is a 6. All right, so that's enough going that way. So let's do some negatives now. Now, the nice part is that you just copy the numbers on the top and switch the signs. Now, this works because you're doing a cube root. Cube root of a negative 1 is a negative 1, but then you're going to multiply it by a 3. So cube root of negative 1 is a negative 1 times 3 is a negative 3. Cube root of a negative 8 is a negative 2 times 3 is a negative 6. Well, I got lost for a second there, sorry. Now you notice there's a symmetry going on here. 0, 1, 8, 0, negative 1, negative 8, 0, 3, 6, 0, negative 3, negative 6. Now this will always happen as long as you take the shift off. So that's why I wanted to do this first because it actually makes it so it's easy to pick your values. So now let's go ahead and put the shift back on here. So let's see, what was our original one? Was that one? Okay, so we want to do left 2, down 1. So we're going to make a new graph over here, or new table, sorry, x, y. Now remember the x, you're going left 2, so you're subtracting 2 from your x's. You're going down 1, so you're subtracting 1 from your y's. Okay, so 8 minus 2 is a 6. 1 minus 2 is a negative 1. 0 minus 2 is a negative 2. Negative 1 minus 2 is a negative 3. And negative 8 minus 2 is a negative 10. Alrighty. So let me just double check that. 8, 6, negative 1, 0, negative 2, negative 3, negative 10. Okay, looks good. So minus 1 from your y's. So every single one of these y's should be subtracted 1. So 6 minus 1 is a 5. 3 minus 1 is a 2. 0 minus 1 is a negative 1. Negative 3 minus 1 is a negative 4. Whoa. There you go. Negative 4. Negative 6 minus 1 is a negative 7. All right, so that's our next graph. So this is our actual graph. This table represents your original equation. Now that's another reason why we took off the shifting, is because if you didn't take this off, you would have had to know that when you put a 6 in, it comes out nice and neat inside of here. Now that's a little bit harder than to just take those off and just figure out perfect cubes. All right, so we're going to graph our graph based off of these numbers. So let me put it back on a double screen, and let's do the graph. So let's move that over a little bit. All right, so here's our graph. Remember, we're basing it off of this right here. So the first point's at 6, 5. So 6, go up 5, and there is your first point. Next point's -1, 2. So at -1, you go up to 2. Okay, next point's at -2, -1. So -2, -1. Okay, next point is at -3, -4. So -3, -4. And next point's at -10, -7, 6, -7. So it's right here, right on the edge of our graph. Okay, so we got a bunch of points here. Now, probably one of the harder parts about this is just knowing how to connect them. I'm seeing a lot of people, they connect it like this, and then it goes way up here for some reason. Now, you got to remember, these are, the way you should connect them is kind of like they're half parabolas. So this is our middle point. So we're going to connect this to this one, and it's kind of like it's a parabola. All right, now for the second part down here, it's like it's another parabola just flipped over. So this is another half parabola. So you're going to connect this to this. Oh no, too far. Okay, I don't like that one. I'm going to erase that. Let's try that again. All right, and yes, I am going to blame this on the pin. All right, there you go. So that is your cubic. That's how you guys graph this one. Now notice that the center used to be at the 0, but it got moved over to the left 2 and down 1, which is what we expected. This 3 right here, what that did was normally this kind of curves up this way a little bit faster, but with the 3 it kind of makes it go, it stretches it up and down a little bit further. Okay? And those are the 3 examples, or those are examples I want you guys to do. We might do some of the extra examples in class if you guys still have questions on it, but that's basically it. All right. Okay. See you guys tomorrow. Bye-bye.